In this video, I'm going to write up the code to allocate and free the memory to pointers, and then draw that out so you see precisely what's going on as we structure this data. So up to this point in the previous video, we allocated a pointer in the registers to a set of pointers that we're going to indicate are in the data memory. So in this case, let's say I did 4, but we haven't allocated any memory to these. So let's first go through the process of allocating this memory. And we're going to promote modularity by doing this in a function. So I'm going to call this void alloc mem. Now to do this, I'm going to first pass the pointer to pointers of the integers. But I also have to pass other information. All this contains is the location that I'm pointing to. It doesn't indicate the size by itself. I have to pass the size as well. So to do that, simply put, comma, and then I'm just going to copy this long unsigned int Pascal size. The next thing I need to do is iterate through the entire loop. So I'm going to create a long unsigned int, I'll call that iter, and in C, especially after the 1999 standard, they insist that you have to define it here in the for loop. And then we're going to say iter is less than Pascal size, and then plus plus iter. Inside, what we need to do is we're going to allocate the memory. So in this case, if I have 4, I have already allocated the pointer to 4 pointers. Now we get to revisit allocating integers. So in this case, I'm going to allocate 1, then 1, 1, 1, 2, 1, 1, 3, 3, 1. So the way I would do this is to say, well, Pascal is the array, and I can just say iter. So now we're at Pascal iter. So let's say we're at 0. So let me change this to purple. So now we're allocating here. I need to give context. So first I'm going to say malloc. Let's say this is a void pointer. And then I need to say 1, I need to allocate 1. Now this is a common mistake when people are working on things like Pascal's triangle. Iter currently is 0, which means we have to do 1. So we're going to do iter plus 1 here. And I'm going to put that in parentheses so I don't unintentionally multiply the malloc or the size of by 1. So we're going to do size of, and we're allocating integers. So this time we're going to do size of int. But we're not done. In production quality compilation, we do not promote this implicitly. We have to do it explicitly. So we're going to do int star. So now we go through and we allocate all of the memory. So here I can say alloc mem Pascal, comma, Pascal size. And so far we're going to be in good shape. So let me compile it, say 4, and it compiles. But what have we not done yet? We haven't freed everything. And in this case, what I've done here is a particularly rough form of memory misallocation, because what I've done is I've successfully freed the array of pointers, but what I haven't done is free this memory. So this is an issue that we're going to fix with our next function, which is the free memory function. So when I do the free memory function, I'm going to say void free mem, and I'm going to pass the same elements here. And I'm going to loop through. So in this case, I'm just going to copy everything, but I'm going to take out what's going to be done inside the loop. In this case, what I'm going to do is I'm just going to free the memory at those specific pointers. So before we have pointer, 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 pointer. If we have 4, and this is pointing to the integers. And now what I need to do is I'm going to iterate through and free each array. And we can do that by saying free Pascal at iter. And now what this is doing is it goes through and it first frees the first one, second one, third one, fourth one, and that frees the integers. And then when we come back into main, this line of code will free everything else. So in order to do that, we need to call free mem. And then we're passing the exact same elements, like so. Now, when I'm writing code with pointers to pointers and data structures, I always will make sure that I allocate and free the memory before I actually do anything else with the data. So we're still working in structure before we actually put the data in. So in this case, I'm going to compile it. Say I ask for 5, and this is going to compile and work fine. So we don't have any segmentation faults, and we've properly allocated all of our pointers to pointers.